Astronomers have made the rare and tantalizing discovery of an Earth-like exoplanet 40 light-years away that may be just a little warmer than our own world. The new paper, Gliese 12b, a temperate Earth-sized planet at 12 parsecs discovered with TESS and CHEOPS, has been published in the monthly notices of the Royal Astronomical Society. The potentially habitable planet, named Gliese 12b, orbits its host star every 12.8 days, is comparable in size to Venus, so slightly smaller than Earth, and has an estimated surface temperature of 40 degrees, 107 degrees, which is lower than most of the 5,000-odd exoplanets confirmed so far. That is assuming it has no atmosphere, however, which is the crucial next step to establishing if it is habitable. It may have an Earth-like atmosphere, one more akin to Venus, which experienced a runaway greenhouse effect that made it a 400°K, 752°K hellhole. No atmosphere, or perhaps a different kind of atmosphere not found in our solar system. Getting an answer is vital because it would reveal if Gliese 12b can maintain temperatures suitable for liquid water, and possibly life, to exist on its surface, while also unlocking answers about how and why Earth and Venus evolved so differently. Gliese 12b is by no means the first Earth-like exoplanet to have been discovered, but as NASA has said, there are only a handful of worlds like it that warrant a closer look. It has been billed as the nearest, transiting, temperate, Earth-size world located to date, and a potential target for further investigation by the James Webb Space Telescope. The closest Earth-like exoplanet to us, and possibly the most famous, is Proxima Centauri b, which is only 4 light-years away. However, because it is not a transiting world, we still have a lot to learn about it, including whether it has an atmosphere and the potential to harbor life. Most exoplanets are discovered using the transit method, where a planet passes in front of its star from our point of view, causing a dip in the host star's brightness. During a transit, the star's light also passes through an exoplanet's atmosphere and some wavelengths get absorbed. Different gas molecules absorb different colors, so the transit provides a set of chemical fingerprints that can be detected by telescopes like Webb. Gliese 12b could also be significant because it may help reveal whether the majority of stars in our Milky Way galaxy, i.e., cool stars, are capable of hosting temperate planets that have atmospheres and are therefore habitable. It orbits a cool red dwarf star called Gliese 12, which is almost 40 light-years away from Earth in the constellation Pisces. Gliese 12b represents one of the best targets to study whether Earth-size planets orbiting cool stars can retain their atmospheres, a crucial step to advance our understanding of habitability on planets across our galaxy, said Shishir Dolakia, a doctoral student at the Centre for Astrophysics at the University of Southern Queensland in Australia. He co-led a research team with Larissa Palathorpe, a doctoral student at the University of Edinburgh and University College London. The exoplanet's host star is about 27% of the size of our Sun, and has a surface temperature that is around 60% of our own star. However, the distance separating Gliese 12 and the new planet is just 7% of the distance between Earth and the Sun. Gliese 12b therefore receives 1.6 times more energy from its star, as Earth does from the Sun, and about 85% of what Venus experiences. This difference in solar radiation is important because it means the planet's surface temperature is highly dependent on its atmospheric conditions. As a comparison to Gliese 12b's estimated surface temperature of 42 degrees Celsius, 107 degrees Celsius, Earth has an average surface temperature of 15 degrees Celsius, 59 degrees Celsius. Atmospheres trap heat and, depending on the type, can change the actual surface temperature substantially, Dolakia explained. We are quoting the planet's equilibrium temperature, which is the temperature the planet would be if it had no atmosphere. Much of the scientific value of this planet is to understand what kind of atmosphere it could have. Since Gliese 12b gets in between the amount of light as Earth and Venus get from the Sun, it will be valuable for bridging the gap between these two planets in our solar system. Palethorpe added, "It is thought that Earth's and Venus's first atmospheres were stripped away and then replenished by volcanic outgassing and bombardments from residual material in the solar system. The Earth is habitable, but Venus is not due to its complete loss of water. Because Gliese 12b is between Earth and Venus in temperature, its atmosphere could teach us a lot about the habitability pathways planets take as they develop.